In the second part of Mod 3A, we are still going to be solving equations, but we are going to use the square root property and the quadratic formula as our techniques. We're going to start out by using the square root property to solve equations that are in the form of ax squared equals c. When you are using the square root property, you take the square root of both sides, and you must remember that you have to do the positive and the negative of the square root of c. For our first example of solving using the square root property, we're going to do a very basic problem. When we are solving a problem like x squared equals 81 using the square root property, we have to remember that we are doing the square root of both sides. The square root of x squared is x. We do plus or minus, and then the square root of 81 is 9. If you think about it, positive 9 squared is 81, and negative 9 squared is also 81. Our second example is also a very basic one. If we do the square root of both sides here, the square root of y squared equals plus or minus the square root of 49. The square root of y squared is y equals plus or minus the square root of 49 is 7. On our next example, we have z squared equals negative 49. If we do the square root of both sides, we would have plus or minus the square root of negative 49. But there is no number that you can square and get a negative answer. So what we say when there is a negative inside the square root is that this is not real. Our next example of x squared equals 72, the process is not going to change. We are still going to take the square root of both sides. So we'll have the square root of x squared equals plus or minus the square root of 72. The problem on this one is that 72 is not a perfect square. The square root of x squared will give us x. We're going to keep that plus or minus on the front. Is there a perfect square that does go into 72? Yes, it's 36 times 2. So our final answer, we're going to keep that plus or minus. The square root of 36 is 6. Pull that outside the radical, and then the square root of 2 stays as is. On example E, doing the square root of both sides, we'll have the square root of x squared equals plus or minus the square root of 45. Square root of x squared is x. Keep your plus or minus. 45 is not a perfect square, but 9 goes into 45, and it is a perfect square. So we're going to break 45 into the square root of 9 times 5. So we're going to have x equals plus or minus the square root of 9 is 3, pull it out, square root of 5, as is. On our next example, our variable is contained within a quantity that's being squared. So we're going to use the same idea. We're still going to take the square root of both sides. So we're going to have the square root of the quantity squared equals plus or minus the square root of 25. The square root of the quantity squared, the square and the square root offset each other, and this leaves us with just the quantity of w plus 10 equals plus or minus, and this 25 is a perfect square, and it would be 5. When you have a problem like this, you now have two separate equations. You have the quantity of w plus 10 equals positive 5, or you have the w plus 10 could equal negative 5. So you solve each of these equations for w. Subtracting 10 on the first equation will give us w equals -5. On the second equation, it'll give us w equals -15. Our last example using the square root property is very similar to the last one. We're still going to do the square root of both sides. So the square root of the quantity squared equals plus or minus the square root of 80. So the square and square root offset each other on the quantity, and we are left with just the u plus 2. What's different about this problem is that 80 is not a perfect square. So we have to think about what perfect square goes into 80, and that is 16 times 5. So our quantity is going to stay the same right now, equals plus or minus. The square root of 16 is 4, and then the square root of 5 stays in the radical. On a problem like this one, you're not done until you have the variable equals. So we need to subtract 2 on both sides. So we're going to have -2 plus or minus 4 square root of 5. We can't combine that. We can't do -2 plus 4 square root of 5. They're not like terms. We have to leave it separate like this. We could write it as two different answers. We could say -2 plus 4 square root of 5, or -2 minus 4 square root of 5. But it's a perfectly acceptable answer to put the plus or minus between. The quadratic formula is a tool that allows us to solve any quadratic equation. You absolutely must have the quadratic formula memorized. The quadratic formula is x equals -b plus or minus the square root of b squared minus 4ac all over 2a. The a is the coefficient of x squared, b is the coefficient of x, and c is the constant. For our first example using the quadratic formula, we are going to use it to solve the quadratic equation of 9x squared minus x minus 2. For practice purposes, let's just make sure everybody knows what each letter is. A is whatever is in front of the squared term, so our A is 9. B is what's in front of the x term, the first power term. In this case, that's a -1. C is the plain number, and in this case, it's -2. So if we put all those into position in our quadratic formula, we say x equals, because x is the variable in our equation, and then we do the opposite of our b, the negative of b. Since our b is -1, we do +1. Plus or minus the square root of, do the b, -1 squared, minus 4 times your a of 9 times your c of -2. All of that goes over 2 times our a, which is 9. So now let's start cleaning up what we've got. We're going to have 1 plus or minus the square root of -1 squared is +1. -4 times 9 is -36 times -2 gives me +72. All of that goes over our 2 times 9, which is 18. So now we need to do that addition that's in the radical. We're going to keep our 1 plus or minus. 1 plus 72 gives me 73 over 18. Check what's in the radical, the square root of 73. That does not simplify. So this is your answer. It is actually 2 answers. It is 1 plus the square root of 73 over 18, or it's 1 minus the square root of 73 over 18. Our next example, we have 6x squared minus 3x minus 1 equals 0. So first, let's note that A is 6, B is -3, C is -1. Putting everything into the quadratic formula, we're going to say x equals, because that's our variable, opposite of our b will be +3, plus or minus the square root of b, which is -3 squared, minus 4 times our a is 6 times our c is -1. That's all inside the square root. And then that entire thing goes over 2 times our a, which is 6. If we start working this and cleaning it up, we're going to keep the 3 out front, plus or minus. In our square root symbol, -3 squared is +9. -4 times 6 gives me -24, times -1 gives me +24. All that goes over 2 times 6, which is 12. So now we have 3 plus or minus the square root of 9 plus 24 is 33 over 12. The square root of 33 does not simplify, so that is your final answer. For our last example on the quadratic formula, we have 2x squared plus 8x minus 1 equals 0. So on this problem, a is 2, b is 8, c is -1. Putting it into our formula, we'll have x equals, the opposite of our b is -8 plus or minus the square root of, the b is 8 squared, minus 4 times a is 2 times -1. All of that goes over 2 times a, which is 2. So we have -8 plus or minus. Now, inside our square root symbol, we're going to have 64. -8 times -1 gives me +8 all over 4. Do the addition of the square root, and we get -8 plus or minus the square root of 72 over 4. Looking at this square root, it does simplify. So we're going to break that square root of 72 into 36 times 2. And that's all over 4. This now gives us -8 plus or minus the square root of 36 is 6. We're going to leave square root of 2 in the radical over 4. What's different about this problem is when you look at all of the numbers outside of radicals, they all divide by 2. So we have to simplify them all. We have to divide all of them by 2. This means that our first term becomes -4 plus or minus 6 divided by 2 leaves me with 3 square root of 2 over 4 divided by 2 is 2. This is our simplified answer. The discriminant is the part of the quadratic formula that's inside the radical. This tells us how many real solutions there are to a quadratic equation. So to use the discriminant, you're going to find b squared minus 4ac. If b squared minus 4ac is greater than 0, there are 2 real solutions to the equation. If b squared minus 4ac equals 0, there is 1 real solution to the equation. If b squared minus 4ac is less than 0, there are no real solutions to the equation. We are going to find the value of the discriminant and the number of solutions to the equation based on the value of the discriminant. We only need to use the part of the quadratic formula that is the b squared minus 4ac. So for this problem, our b is -7. We're going to square that. minus 4 times the a is 5 times the c is 1. This will give us 49 minus 20, which equals 29. The value of our discriminant is 29. Because it is a number that is greater than 0, we will have two real solutions. For our next example, our b is negative 9, so we need to square that, minus 4 times our a is 3, our c is 2. Negative 9 squared is 81. Multiply the 4 times 3 times 2, we will have minus 24. If we take 81 minus 24, we will get 57. So the value of our discriminant is 57. Since it's positive, we have two real solutions. On example C, if we take our b, which is positive 8, and square it, and do minus 4 times our a is negative 9, times our c is negative 4. This will give us positive 64, and then we have a negative times a negative times a negative, which is a negative. 36 times 4 is 144. This will give us negative 80 as the value of our discriminant. If the discriminant is negative, there are no real solutions. On our last example, start with your b squared, which is going to be negative 6 squared, minus 4 times the a of 9 times the c of 1. Negative 6 squared is 36. Negative 4 times 9 times 1 is negative 36. So the value of our discriminant is 0. When this happens, you have one real solution.